which is very brief. I'm going to do that brief. Showing us that when we have two means, we can also do confidence intervals. Now I showed you the hypothesis test. Just as in the one sample case, we can do confidence intervals that quantifies the difference between the two means. Here is one version of it. Here is a version that uses, the form of the interval is like we know it from one sample. It's the observed difference plus minus something from a distribution. In this situation, this version, it's a set. Because I assume that I have large samples for this version. And then I have plugged in the two computed variances in this. Here is another version. Here is a version that uses the pooled variance. That is, you can see this whole expression here is just square root SP. And that is, more easily expressed, SP. I just use this pooled variance, and then I use the T instead, and then I can use it for small samples. However, there is a little additional assumption, and that's the one I will discuss with you next time, because I didn't plan, it's not because we are late, I didn't plan to discuss it today. That's this assumption. The assumption of pooling the two variance estimates together, in fact, is that it makes good sense to make a joint. The fact that they are assumed to be more or less the same. If that is not the case, we would have to do something differently. We would have to separate them and not pool them. And we'll get back to that next time. It can be done, so it's not a big issue. It's just one of those little technical things that we have to think about. Should we do it? I think now I'll be a bit lazy. I love being lazy. Let me do like this. Now I do the t-test, where I do not put any options on whether it should be one or two-sided. Having done that, so I use this t-test function. Having done that, I see now the alternative is that the true difference in means, stop doing that, is not equal to 0. However, I'm not doing this to get a hypothesis test. I'm doing a two-sided version of the function call for me to get the confidence interval. That is using the fact that I showed you in the rep today, that a confidence interval is the same, is equivalent to the two-sided hypothesis test. Whether we want to do the two-sided hypothesis test at all, it doesn't change the fact that mathematically the confidence interval is equivalent to the two-sided hypothesis test, whether we want to do it or not. So here is the confidence interval actually given to us. So that is using the formula I just showed you without plugging in everything and going through the computations. I get the result, minus 3.42 up to minus 0.59. Should I try if I can remember that? Just 1 second. Oh, that's difficult to remember. Also because I pressed the wrong buttons here. Minus 3, I forgot it already. 3. Can you see or remember the results? I try maybe one number at a time, then maybe I can do it. 4.242. Oh, that was a good feeling. Minus 0.59. Whoa, I'm good now. That was the result. Without going through plugging into the formula, but showing you that the R function actually plugs in. Please note that the formula just consists of the SP, the two means, and then finding the proper T, which was the one I found just actually, I'm sorry I didn't find that one, but it could be found using the QT function or table 4. Right. This was as much as I would say about confidence intervals for the difference of means. So we make a jump to the next